In hypothesis testing, the two approaches are used. One is called critical value approach, is a basic approach, and the p-value approach is an extended approach. P-value approach is generally used whenever we are working with the software. SPSS will provide us the p-value of the given problem. The critical value approach, we have to form a critical region. Critical region is those region. Critical region is a region in which if the value of the test statistics falls, we will reject the null hypothesis. Or our conclusion will be there is no sufficient evidence in support of H naught. We will discuss these two approaches in the remaining presentation. Firstly, we will cover the critical region approach. In the critical region approach, we have to form critical region. What the critical regions are? Suppose our null hypothesis, our alternate hypothesis is number one. This is number one. In our null alternate hypothesis, we have not equal to sign. If we have a not equal to sign, then the critical region will be formed in this way. Your normally distributed graph, and alpha will be distributed on the two sides, alpha by 2 on the left side and alpha by 2 on the right side. This alpha by 2 will be taken into the table. From the table, we will get the two values. These two values are known as critical values. So what the critical values are? Critical values are these 2 points in a two-sided region. And this is our shaded region. If the test statistics, the value of the test statistics is fall under the critical region, there is no evidence in support of H naught. If the value of the test statistics will fall within the non-rejection region or acceptance region, this will support our null hypothesis. So if the number one, if in alternate hypothesis we have a not equal to sign, the two-sided region will have, this is called critical region, and these 2 points are known as critical points or the critical values. And non-rejection is unshaded region is known as non-rejection region. In case of the number two, whenever we have a left-sided null hypothesis, alternate hypothesis, left-sided null hypothesis. So in case of number two, we have to create one-sided region, which is on the left side only. So we have left-sided region, only this. Entire alpha will be considered on the left side, and non-rejection region will be on right side. Only one critical value will be there. This is the critical value, and this is alpha. And this region is known as 1 minus alpha, or we call it as level of confidence. This is level of confidence. This is level of significance alpha. In case of right side or greater than same symbol in the alternate hypothesis, this will be number 3. In case of number 3, we have to form one-sided region. That side is the right side. This is the case, and the entire alpha will be considered on the right side. This approach is known as the critical region approach, in which we have to calculate the value of the test statistics. If the value of test statistics falls in the critical region, we will not accept the null hypothesis. The evidence will not support our null hypothesis. This is critical value. This is alpha. Entire alpha will be taken on the right side. This is 1 minus alpha. What is the value of the test statistics? If we are using the Z statistics, then all of you are familiar with the Z statistics in case of central limit theorem. X bar minus mu sigma upon n root. This is called z test. Z test, the value of Z test is to be computed by putting X bar and by putting the mu, by putting the standard deviation of population and the sample size. The Z statistics is computed. Then this value of Z statistics will be compared with these two critical values. If Z statistics is above the point B, this is, I'm assuming as point B. I'm assuming this is point A. If the value of Z statistics is in between A and B, the data provides sufficient evidence in favor of the H naught. Data provides sufficient evidence in favor of H naught. If Z statistic, the value of Z statistics is above B, like it is more than B, so we will reject the null hypothesis. Or we will use the term data provides sufficient evidence in support of alternate hypothesis. In this case, we will use the term mean is above the value of null hypothesis, value described in null hypothesis, which is mu naught. If Z statistics is below the value of A, we will reject from the left side, and our conclusion will be the actual value of the parameter will be less than the specified value. So we have to take the two different decisions. Our H1, our HA is what? Our HA is, in the case of 1, HA is mu is not equal to mu naught. Mu is not equal to mu naught. Mu naught is a number which is described in the hypothesis. If the value of Z is more than B, our decision will be the mean will be greater than mu naught. If the value of Z statistics is below A, our decision will be mu is less than mu naught. So that is the way in which we have to split this two-sided alternate hypothesis. In our decision, we have to put the decision either greater than B or less than A. We will not find in the final conclusion, we will not use the term that mu is not equal to mu naught. So this is the way of taking the decision in case of this. Suppose this is A in case of second version, and suppose this is value B in the third version. If the value of Z statistics is above A, the decision will be in support of A. If the value of Z statistics is below A, the decision will not be in support of H naught. So our decision will be in support of H1 or HA. Our decision will be what? Mean is less than mu naught. This is alternate hypothesis, and mean is greater than mu naught. This is our decision in the third case. In the third case, if the value of Z statistics is above B, it means it's fall in this critical region. Then our decision will be data provides sufficient evidence in support of H1. In support of H1. H1 is what? Mu is greater than mu naught. This is the way of working in critical region approach. Two-tailed test, two-sided. This is the two critical values. You can see here. If it is below this number, then we can use the term mu is less than mu naught. If it is above this number, mu is greater than mu naught. If the value of the Z statistics or value of any statistics test statistics falls in between A and B, our decision will be mu and mu naught are same. This is your null hypothesis. This is in our alternate hypothesis. Actually, we have mu is not equal to mu naught, but in decision we have either mu is less than mu naught or mu is greater than mu naught. Any one of these two decision will be taken. In a left-sided test, alternate hypothesis is less than. If the value of test statistics is below A, our decision will be less than mu naught, and so on. It is right tail, the shaded region will be on the right side, and the cut point will be this. If the value of the test statistics is above this number, our data support HA, not in H naught. Now we have to consider this example. This is the example in which we have the data of drive of a golf ball is 275 yard. This is the average drive. Average is given here. The average value of the golf ball is 275 yard. Achha, Gene is skeptical and ask for the substantiation to that, and Jack hits 25 drives. This is the sample size. Sample size is of 25. Is not large sample size, but this is the case. These are the distances of these not greater than. It is actually is equal to 25. First drive to 66 yards, second drive to 54 yards, and the last drive hit 295 yards. So this is our data. And what is to be checked in this? Whether the average drive for the all population is 275 yard. This is the null hypothesis that we have to check. What is the population in this example? The population is the all drives made by Jack. All drives made by Jack is a population, and these 25 drives by Jack is a sample. So we have two things: all drives by Jack is a population, and 25 drives by Jack is a sample. And the sample mean is given here. The sample mean is 264.4. This is sample mean. And what is expected mean? 264.4. And your population mean is 275 yards. The population mean that we have to test. We have to test the standard value of Jack, which is 275, which is described in the hypothesis. So you have to state the null hypothesis at the 5% level of significance. This is alpha. Do the data provide sufficient evidence to conclude that the Jack mean drive distance is less than 275 yards? This is our alternate hypothesis. And we use the following steps to answer the question. So H naught is what? H naught is this. And H1 is, or HA is less than, mean is less than 275 yards because it is stated in the statement, 275 yards. And the sample mean is 264, sample size is 25. We have no idea about the population size in the problem, and it is of course not required. To state the null hypothesis and or alternate hypothesis, this is part A. Discuss the logic of the test statistics. Test statistics is what? Whether the t-test or the z-test is to be used. As we already described, z-test will be used if we have the value of population standard deviation. The t-test will be used if we have the value of population standard deviation unknown. The t-test will be used. But here the logic of test is what? Whatever the test we will use, if the value of the test statistics is less than this, because we will use a left-sided version, because in alternate hypothesis we have a less than sign. If the value of the test statistics is below this number, the data provides sufficient evidence in support of H1, not in H naught. So that is the logic of the hypothesis test. You have to obtain a criterion for deciding whether to reject the null hypothesis or in favor of the alternate hypothesis. That is the criteria. If your value of the test statistics is below this number, this is the tabular value. This is Z alpha. Where from we will get this number? This number will be obtained from the table by looking alpha. Alpha in this problem is 5%. So we have to take a value from the Z table if we are using Z statistics. If we are using T statistics, we have to obtain a value T alpha here, not Z alpha. So Z 0.05. So you can obtain this number from the table, Z 0.05. If your value of test statistics is below this number, we will use a conclusion that data provides sufficient evidence in favor of H1. And that is basically the solution of in the problem. Last statement is saying what? Population standard deviation of all such drive distances is 20 yards. Population standard deviation is also known. Sigma is equal to 25 yards. If the population standard deviation is given, then we can use Z statistics instead of T statistics. Now we are going to complete the problem. The null hypothesis, 70 to 75 yards, Jack claim, and less than 275 yards in alternate hypothesis. And then we have to find the mu x bar is equal to mu 275 yards. According to the central limit theorem, we can use the central limit theorem because the sample size is 25. As earlier I told you, the sample size of 30 is a large sample size, but sometimes statisticians use light criteria, and that criteria is a size of 25. So here we have a size of 25. We can apply this test here. The size of 25 without testing the normality, we are moving. In this problem, we did not test the normality. So we can check the normality of this data. If the data is normally distributed, then we can take the decision, but we can assume this 25 is a large sample, and without applying the test of normality, we are using it, central limit theorem. Sigma x bar is equal to sigma upon n root. It is 20 upon under root 25. This is the standard error of mean. This is the standard error of the sampling distribution of mean, or you can call it as this is the mean of the sampling distribution of mean. The mean of the sampling distribution of mean is equal to the population mean, is the theorem number 1. And the theorem number 2 was what? Standard error is equal to sigma upon n root. So these two numbers are computed, and then the Z statistics is calculated. Formula of Z statistics, you can see x bar minus mu sigma upon n root. As I already told you why we are using Z statistics. if the population standard deviation is known. Now these numbers are substituted here, 275 and this is 4, and the value of x bar is also given in the problem. We have to put that value of x bar so that we can calculate the value of z. The value of z by putting this number, this is the formula of z that can be easily calculated by substituting the sample mean. Now we are going to form critical region. How critical region is formed? In the critical region, we have to use Z alpha. As I told you, alpha is given, a confidence interval 95, and the value of level of significance is 5%. The 5% value Z 0.05 is obtained from the Z table. And this is minus 1.64. Minus 1.64 is the critical value. Now we have to calculate the value of Z statistics by substituting X bar here. If this value of Z statistics is below minus 1.64, we will take a decision that the data will not in support of H naught. Data does not support the H naught and it is in favor of H1. If value of Z score, Z statistics is above minus 1.64, we will take a decision that data support H naught, and the null hypothesis is assumed to be true. That is the case of solving the problem. Now in this case, the value of x bar is 264, and if the value of x bar is substituted into the Z formula, Z statistics, it is minus 2.65, and this is minus 1.64. This is minus 1.64, and the value of Z statistics computed, the value is minus 2.65. It is minus 2.65. So actually, this Z statistics is below minus 1.64 here. This is the value which is indicated here by the black dot. This is minus 2.65. So our decision will be what? Our decision will be data provides sufficient evidence in favor of H1 and we will reject the null hypothesis. This is our decision. At 5% level of significance, data provides sufficient evidence to conclude that the Jack mean driving distance is less than his claimed of 275 yard. It means alternate hypothesis is assumed to be true and the null hypothesis is assumed to be false. This is the complete procedure of implementing a hypothesis test by using critical region approach. We are summarizing the steps of hypothesis testing by critical value approach. These are the 6 steps, and all over there in the book and in the course, we will use these 6 steps. So you have to remember these six steps, and if you have to solve a problem by using the critical region approach, you can apply these 6 steps. In the first step, state the null and alternate hypothesis. Level of significance is what? If it is not provided, 5% is a moderate value, you can assume. Compute the value of test statistics either by t-test or by t-test, z-test if we are testing the mean. If we are testing the variance, we can use chi-square test, or if we are comparing two variances, we can use f-test. So these are the 4 basic tests. In step number 3, depending on the problem, whether it is a problem of mean or variance, if it is the problem of mean, we can use Z or T test. If it is the problem of variance, one variance, we can use chi-square test. And if we have to compare the two variances, we can use f-test. So these are the 4 different tests that we have to learn throughout the course. Now then critical region, critical values are to be taken from table and decision will be taken according to the criterion. Criterion is what? If the value of statistics in step 3 is falling in the acceptance region, then the data provides sufficient evidence in support of H naught. If the value of test statistics is in critical region, we will take a decision that data provides sufficient evidence in support of H1. And then finally the result, interpret interpret the result. So these are the 6 steps which we have to apply whenever we are solving a problem by using critical region approach. I will record a separate video for p-value approach. That is why I'm not considering the slides of the p-value here in this recording. This is procedure T1. As I defined previously, the procedure E1, estimation procedure 1, this is testing procedure 1. T1 stands for the, and in the procedure booklet, we have all around 15 procedure, T1 up to T15. So these 15 procedures have the 6 steps of hypothesis testing. In hypothesis testing, if the data support the assumptions, if the data follows the assumptions, we have to apply the 6 steps. 6 steps are already defined. You have to take H naught and H1. H naught will be assumed as equal to, H1 will be assumed as either not equal to, less than, greater than, depending on the research statement. Then alpha is to be taken. If not provided, you can assume it as 5% as a moderate value of alpha. Then you have to compute Z statistics if the population standard deviation is known. If the population standard deviation is unknown, you can use the T statistics. These are the steps of the critical region, and these are the steps of p-value. I am not considering the step number 4 by p-value. We will consider it using a software, but here we are using this step. In this step, we have to form the critical regions. If it is two-sided, then this critical region will be used. If it is one-sided, either this one or this one. After forming the critical region, decision will be taken, and conclusion will be here. So you have to take finally the conclusion of hypothesis test. But remember, hypothesis test is exact normal for normal population. If the population is normal, then hypothesis test will be exact normal. If the population is not normal, but the sample size is large, according to the central limit theorem, it is approximately normal. It is approximately normal if the sample size is large. So we have to take the advantage of central limit theorem, or if the population is normal, then we can directly use x bar will be normal. So these decisions were described in the chapter of sampling distributions. Now one complete example is here. In this example, the prices of book are given. As a random sample, 40 history books are selected at random and their prices are given here. At 1% level of significance, do the data provide sufficient evidence to conclude that this year mean price of all history book has increased from the 2005 mean price of 78.01. So we have a standard value by which we are comparing this year mean value. So this is the 278 point. This is the value of hypothesis mu naught. We have to check the sample mean value with the this population mean value. Assume that the population standard deviation is 7.61. The population standard deviation is given. We can use that statistics, and this is the value of the hypothesis in which we have to check mean is 78 increased. The alternate hypothesis will be what? Population mean will be greater than 78.01, and we have to calculate the sample mean from this data. So initially the sample size is large. There is no need to check the normality of the data, but we can check the normality for assessing the outliers. Null hypothesis is mean price of this year is equal to 78, which is the mean price of 2005. Now, mean price is greater than 78 as it is expected in alternate hypothesis. We have to decide the level of significance. It is given in the problem at 1%. The 1% means what? The value of alpha is 1%. The 1% value is taken, alpha is 0.01. We have to calculate Z statistics because sigma is known. And the sample mean is 81.4, population mean is 78 point this. This is the value of Z statistics. Now Z statistics is computed. Now we have to form the critical lesion as we have a greater than sign in alternate hypothesis. We have to use the right tail test. So critical region will be right side. I'm not using the p-value approach here because it will be recorded separately. I'm using a simple approach, which is critical region approach. The Z 0.01 is to be 0.01 is look up into that Z table and 2.33 will be the value. Now our value of the Z statistics is which is computed is 2.85. Now we have to compare. This is called Z observed. Z observed is this value, and the Z observed and Z critical. This is Z critical. Z observed 2.85 is more than 2.33. The data provides sufficient evidence in support of H1. What is the H1? The average price is larger than the expected price of 2005. Final conclusion is here. At 1% level of significance, data provides sufficient evidence to conclude that this year mean retail price of all history books has increased from 2005 mean, which was 78.01. This is the end of critical lesion approach. Few or more examples are in this presentation that you have to cover yourself.